two more classes left, and today is actually the last one. We learned something new, and the next two classes we'll just do review, and then I'll send you a final test. Okay, so today we're actually going to work on probability. So a lot of times, like we're facing something could happen in different ways. Like say you flip a coin and it would ends up either a head up or tails up. And if you throw a die, and it could have 1 or 2 or 3 or 4 or 5 or 6. So or like when the team plays, so team either lose or win, and sometimes might be a tie. But now in this case, how do we use math to help us? So math here is to notice that trying to find the pattern. Like say, if you throw a die, flip a coin is either heads up or tails up, but assume that it's a good coin, and hello, Mia. We just got started. Okay, we're going. This is we're going to learn probability. Probability sounds fancy, but it's really just something like we say, what is the chance, or chances are, and it say like things which could have more than one different outcomes, and sometimes we have to make estimation as say which one what would happen more likely. So math, I just talk about flip a coin, either hands up or tails up. So you can just keep trying it, and as you try many times, and there is this interesting pattern will come, is that almost half the time you get heads up, and half the time you got tails up. And hello, Grayson. So so therefore we see that the probability of heads up is half, and probability tails up is also half. So we add together, that's right, will give us 1. So now we have something which is from 0 to 1. So this is what probability is. When you got a probability 0, it means it will never happen. And you got 1, that means it will happen. For sure, it will happen. Okay. For example, if you have a fake coin that both sides are heads, then no matter how hard you try, you won't get tail. So the probability to have a tail is 0, but the probability to get a head is 1, because that's for sure. You always get heads up if you get a fake coin that both sides are heads. So we got this kind of like a scale here from 0 to 1. Sometimes we write this as 0 and the other as 100%, and we know that 100% is 1. So, and if you get something just 0.5, we call half-half. That means they have the equal probability, either happens one way or the other. And so when we have a good coin, we call that unbiased coin. Then that probability getting head is half, probability get tail is also half. Okay, and we can also looking at when you throw a die, and that's what we do when we play games. A lot of times when you die, and it could something come up. So a standard die, just like have 6 numbers because it's basically the cube. Cube has 6 faces. And so you can see that if it's unbiased die, then the number of 1 or number of 2, number of 3, number of 4, number of 5, number 6. So if you're going to throw a die like thousands and 10,000 times, you'll find that pretty much each number get 1/6. So the probability get 1 is 1/6. Probability get 2 is also 1/6. Those are called unbiased die. And all the way to 6 is 1/6. So therefore, when we study probabilities, we don't even going to throw the dice as many times as possible. That's just kind of waste a lot of time. We just notice that how many different outcomes. Well, if you have a die, we got 6 outcomes, and 1, 2, 3, 4, 5, 6. So 1 is just 1/6 of those. If you got 2, which is also 1/6 of those. So that way we can calculate probability pretty easily. Similarly, when we're doing tossing a coin, we know there are just 2 possible outcomes. So therefore, to get the head is half, to get the tail, and it's also half. Okay, are we good on this one? All right, wonderful. So now we're going to looking at some examples of probability. Okay, so first of all, we know that just get a coin. If you throw the coin, half the times hit tail, half the times head. Well, but what is the probability that you do that like twice? And what's probability you got at least one head? Well, if you got twice, so here's the 4 different outcomes. We got head, 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 tail, tail, head, and tail, tail. So we got 4 different outcomes. So that's 4 on the denominator. Now, how many times we get at least one head? Well, let's see. 1, 2, 3. So therefore, the probability to get at least one head is 3 out of 4. Yeah, are we good on this one? Thank you, Mia. Thank you, Mason. Rodri and Grayson, are you guys good? Yeah, Rodri? All right. So you can see that this is how we do probability, is that just we list out all the possible outcomes and figure out how many times whatever the event we call, we're trying to find probability, how many times that happened. So now we're going to looking at what happens if you throw a die 3 times. Well, through die 3 times, what we got? We got head, 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 tail. We could head, tail, head, and could have tail, head, tail. And then we can, oh, sorry, head, head. Then we're going to looking at 2 tails. Tail, tail, head, and tail, head, tail. And we also could have head, tail, tail. So how many we have? 1, 2, 3, 4, 5, 6, 7. There's one more, tail, tail, tail. So we got 8 of those. Now, in this case, let's see. How many times, what's the probability we got 2 heads? Well, probability we got 8 altogether. Probability we get 2 heads. We got 1, 2, and 3. So therefore, that's 3A. Okay? Okay. Roger, Grayson, are we good? Okay. So now I want you to do a practice here. So we're looking at this example. We're going to have flipped a coin 3 times. Now, what the probability that you get one tail? Just get exactly one tail. Well, make sure you count it right, okay? We know we got 8 different outcomes, but how many outcomes that you only have one tail? And the probability is always a ratio, okay? In this case, it's something, yep. Good job, Raji. Yeah, good job, Mia. Okay, Grayson, what's your answer?
Can you repeat the question?
Well, finding the probability that you only got one tail, that we threw the dice 3 times.
What's the question? Is it how many times it's just heads?
How many probability? What's the probability of only get one tail? Okay, well, let's see. We know there are 8 different outcomes. So that's 8 on the bottom. And then we notice that how many different outcomes we got a tail? Well, you can see here, this is one tail. There's another one tail. There's another one tail. This is hat. So therefore, is 3 out of 8. So that's probability to get just exactly one tail. Okay. Yeah. Thank you, Mia. Thank you, Roger. Thank you. Okay, thank Mason. Thank you, Grayson. Okay, now we put something a little bit different. Okay, now what's the probability you got at least one tail? So now it's changed to at least. And see what you got. And it's going to be a ratio, okay? It's how many times? Yeah, good job, Mason. Good job, Roger. Good job, Mia. Yeah, Grayson. Yeah, what you got? So we're trying to find out. We'll find out the probability of getting at least one tail. Well, let's see. we're talking about at least one tail. That means could have one tail, two tails, or three tails. Now you can hear we got 1, 2, 3, and then we got 4, 5, 6, 7. So it's 7 out of 8. Okay, are we good, Grayson? Okay, so now we're going to looking at we're going to looking at a die. Okay, we're going through a die. We know that with one the 6 numbers 1 through 6 each time each one has a probability of 1/6, but we're going to have 2 dice. So you got 2 dice. Now in this case, what's the probability of to get the sum of the 2 dice is 6. So you throw 2 dice, and you add up whatever the number on the face, and we're trying to figure out what when the sum of 2 dice is 6. So what kind of probability that is. Yeah, if you don't know how to do it, you can just type IDK. Yeah, what you got? Well, first of all, looking at how many outcomes, we know this one could be 1 through 6, and this one also 1 through 6. So therefore, we got 36 different outcomes. And so that's our denominator. Now, how many times we can get the sum is 6? Well, we could have 1, 5, or 5, 2, 1. We could have 2, 4, or 4, 2. And then we have 3, 3. So 1, 2, 3, 4, 5. So it's 5 out of 36. Okay, are we good on this one? Yeah, Grayson, you good? All right, now we're going to change a little different. So instead of looking for sum, we're looking at the product. So find the first number on the first die, number on the first die, and then the number on the second, and multiply them. So we're talking about the product is 6. So what is that probability? job, Mason. Hmm.
What are we trying to see the probability of?
We find the probability when the product of the two dice, number on the two dice, is 6. So we know that we have 36 different outcomes. Yeah, we just figure out how many outcomes that will get the product is 6. Yeah, Rodri? Yeah, we'll talk about, well, here is about product. What two number multiply give you 6? Hi, Rodri, are you there? Okay, well, what's your answer? And Grayson, what's your answer? All right. So first of all, the number you gave should be a ratio, okay? It won't be just a one, like 3 or 4, won't be that. It's be a ratio. And we know the denominator has to be 36 because there are 36 different outcomes. Well, how many outcomes we can get 6, the product? Well, we got 1, 6, or 6, 1, or 2 times 3 is 6, 2 is 3, or 3, 2. And that's all we have. So that our probability is 4/30th. Then we can simplify that to 1/9. Okay. Are we good on this one? Yeah, make sure you really understand it, okay? All right, so let's do some more practice. So this time we're going to change that into finding the probability that the sum is 10, okay? The sum of two dice is 10. So now we're looking at this. Only two number add together is 10. Good job, Raji. Good job, Mason. Okay, Grayson. Okay, well, we know that, again, the denominator is 36. Well, how many different ways we can get 10 out of 2 dice? Well, we can either get 6, 4, or 4, 6, or 5, 5. So we only got 3. So in that case, it's 3 out of 36. Then we can simplify that to 1/12. Okay, are we good on this one? Thank you, Grayson. Thank you, Raji. Thank you, Mia. Okay, now change that into, how about the sum of the 2 die is 7. Good job, Mason. And you can simplifying it, okay? Yeah, good job, Mason. Good job, Raji. Yeah.
Can you repeat the question again?
Or find the probability that the sum of 2 dice is 7. See here. Yeah, good job, Roger. Mia, what's the answer? Okay, Grayson? Again, Grayson, the number is not going to be like 3 or 4 or 5. The number has to be a ratio. Good? Because we're talking about probability. Probability is always less than 1. So we know that the number of different outcomes is 36. So 36 is denominator. Now, if for the sum of two dice to 7, what can we have? Well, it's either 1, 6 or 6, 1. So the first one is 1, second one is 6, add together, give us 7. Or first one is 6, second one is 1, add together 7. Well, what else we have? We could have 5, 2, or 2, 5, or 3, 4, or 4, 3. So that's all the outcomes that when you add them, the two numbers, you got 7. So how many we got? 1, 2, 3, 4, 5, 6. So it's 6 over 36, which is 1/6. Okay, are we good on this one? Okay, let's try. So this time we change that to what's the probability that the sum is 5? Okay. Good job, Roger. Good job, Mason. And also simplifying it if you can, okay? Good job, Mason. Yeah, good job, Roger. Hello, Mia, what you got? Very good. And so we know it is 36 on the bottom. Well, how many outcome we got 4? We could have 1, 4, or 4, 1, or 2, 3, and 3, 2. And that's all we have. So we got 1, 2, 3, 4. So 4 out of 36. If we simplifying this, is 1 out of 9. Yep. Are we good on this? Okay. All right. let's try a couple more, okay, to make sure you understand this, because this concept is, it's not hard, but this concept is very important to understand it, so you can understand how to do probability. Okay, so now we're going to change that. Instead of talking about sum, we're talking about product. So when we multiply product, so we do is, in this case, is 12. And see what you have. Well, make sure you got the counts right. So what times what give you 12? How many different ways you can have it? Good job, Mia. Good job, Mason. Okay, so on this one, we can see still out of 36, but we see that to get 12, either 2, 6, 2 times 6, 12, or 6, 2, and we could have 3, 4, or 4, 3. So we got 1, 2, 3, 4, 4, 30, 36, which is 1, 9. Okay, are we good on this one? Yeah. Now, another type of problem is to with a spinner. So you probably have seen this. So let's see, this is 1, 2, 3, 4, 5. Now, normally they have kind of needle, some kind of like point to the spinner. So in this case, this is on 1. When you spin it, you could get 2, could get 3, could get 4, could get 5. Now let's assume this is actually it's a good spinner, which we call unbiased. And now, so therefore, each time the probability could get 1, 2, 3, 4, 5. That each one is just 1/5. So that's called so each one had the same chance to be and to be right under the needle. Okay, so now we're going to call have a we're trying the probability that when this spin this twice, that the sum of the two spins is, say, 5. Okay, well, let's see how many different outcomes we could have. The first one could get 1, second one could get 1 or 2 or 3 or 4 or 5. The first one could get 2, we got 1, 2, 3, 4, 5 for the second one. What will come down to is that 5, we got 1, 2, 3, 4, 5. So altogether, we got 25 different outcomes. So that serves as our denominator. And so in order to figure out when spin that twice, the sum is 5. We'll see how many different outcomes. We could have 1, 4, or 4, 1, or 2, 3, or 3, 2. So that's 4. So 4 out of 25. Good. Thank you, Nathan. Thank you, Mia. Thank you, Roger. Grayson, are we good? Hello, Grayson, are you good? Grayson, can you hear me? Hello, Grayson? Okay, all right. So now we're going to looking at the probability that when you spin this twice, what is the probability that the sum of the two spin is let's see, is 6. Good job, Raji. Yeah, then just need to simplify it. Good job, Raji. Yeah. Yeah, make sure our denominator is 25 because that we got 25 different outcomes. And we just need to see how many events give us the sum is 6. Yeah, good job. Good job, Grayson. Yeah, good job, Mia. Okay. So in order to get 6, we either 1, 5, 5, 5, 1, 2, 3, or 3, 2, or 3, 3. So we got 1, 2, 3, 4, 5. So it's 5 out of 25. Very good. All right. Now let's try another one. What is the probability that you'll end up with a 5? Good job, Roger. Good job, Mason. Good job, Mia. Grayson, what you got? All right, okay, let's see how many ways we can get 5. We could have got 1, 4, or 4, 1, or 2, 3, and 3, 2. So it's 4 out of 25. Okay, we good? Okay, now I'll give you one, it's going to be a challenge one. Now we're going to looking at we got this spinner, we spin that twice. 2 times, and we're trying to find oh, what happened? Let me go back. Happened to my spinner. Okay, so we got a spinner. Okay, we're going to do that twice. And what's the probability that the sum is even? Okay. Yeah, we're talking about the sum is even. You can try out. It's good. Yeah. So do the same thing, just to list out all the events that the sum is even. So it's going to work out like, suppose the first spin is got 1. What happened to this second spin to get the sum or to get the even? You just list that out. All right, let's see how we do this one. Again, we know all together is 25. So let's see. That's our first spinner and our second. Okay. Now, if we see the first one is 1, good job, Mason. Then the second can be 3, 1, 3, and 5. So we got 3 outcomes. What happens to the first one is 2, then the second has to be 2 and 4 to get even, and 3 will get the same, 1, 3, and 5, and 4, of course, will get 2 and 4. And then we got 5. That's 1, 3, 5. So we got 3 here, 2 here, 3 for this situation, 2 for that, 3 for that, 2 for that. Then there's another 3 here. So 3 plus 2 is 5. 3 plus 5, 5 plus 5, 10 plus 3. We got 13. Good. Very good. Okay. Now we're going to your final problem. This is going to be interesting. Is that you're going to put 3 persons in a row, and so you got the first person. So you got 3 persons, say A, B, C. You put them on a row, and what's the probability that the tallest one is right in the middle? Okay, so you can assume A is your tallest one. So what's the probability that A is right in the middle? So we use same technique. Figure out how many different ways you can set 3 people in a row, and then you find how many ways that A, the tallest one, is right in the middle. Good job, Raji. Okay, let's see how we do this one. Okay, first of all, we want to figure out how many different ways we can set them. Remember we learned last time how many different ways we can do that. So for the first one, we have 3 choices. Second one, we got 2. Last one, just 1. So we got 6 different way we can set those people. But to have the tallest in the middle, that says RA, then we only have either BAC or CAB, just 2. So it's 2 out of 6, which is 1/3. So that's probability to have the tallest in the middle. Okay, are we good here? Yeah, thank you. Thank you, Grayson. Thank you, Mason. Thank you, Raji. Thank you, Mia. All right, so that's what we have. Okay, so this will be our we still have 2 more classes to go, and we're going to do reviews, okay, in the next 2 weeks. All right, I'll see you guys next week. Bye.